Hello friends, Lloyd Herlichka here once more, documenting another record find I found yesterday. I'm making this video late, so it was actually Friday afternoon I had found another surprise, I thought anyway. It's a test record put out by it used to be the Components Turntable Corporation, and they were out of Denville, New Jersey. Here's the actual record. Front side, back side. You probably won't be able to read the details on it from the just what I just showed up there, but I will have them pasted into the video, which is going to be part of this video after I'm done giving a brief over it. It's a test record that was made in at least 1955. It might even be from 1954, because I got an ad from a July 1955 back issue of Audio magazine, and it has the turntables that they mention on this record in that ad, and I thought it was pretty interesting. And it must have been a very impressive turntable design, because the specifications were showing like a rumble figure, or you could even refer to it as signal to noise ratio, but the noise, the rumble and noise are down at least 70 decibels from the 0 decibel reference of a signal that was, the peak was at 0 dB. I'm assuming that they're using the 0 dB as their reference, but it's a pretty good specification, so that would mean it would be a very quiet turntable even by today's standards. Wow and Flutter, which this record is mainly for testing of wow and Flutter. The wow and Flutter of that turntable that's in that ad, I'm going to have a picture of that too in the video along with the photo scans of the record. The wow and Flutter though are rated at no more than 0.05%. So very good wow and Flutter figures too. That refers to variations in pitch. Like if you have a steady tone, and if it starts to waver, if the turntable speed gets, or if the record is not centered perfectly, you're going to hear that, change in pitch, like up and down, and wouldn't be a constant steady tone. So the lower the wow and Flutter figure, the more steady it'll sound, like it should. But this engineer or technician, I don't know what his name is. It's not mentioned on the label at all, so all I know, it's an audio technician or an engineer from the Components Corporation, and I don't know whatever became of this corporation, if they got phased into a different brand or got bought up by somebody else or just completely went out of business, but it looked like they had pretty good turntables. So otherwise, I'm going to go ahead and turn it over to the engineer or technician from the Components Corporation and let him document everything better for you, so you can get a good understanding of what this record is about. So I hope you find it somewhat interesting, and I think it's interesting because it's part of the history of high fidelity, how we're enjoying all our old classic songs that we hear now from years past. It's nice to know the technology that helped make those recordings too, so we can appreciate the technology behind the old recordings. So, but otherwise, I'm going to go ahead and let him explain it better. So hope you find it a little bit interesting. So talk to you later. Bye.
Wow is defined as a slow variation of turntable speed, usually associated with a once-around change in pitch. Here are two typical examples. These samples of wow were actually produced by deliberately setting a record off-center. The two tones represent 0.5% peak-to-peak wow and 1% peak-to-peak wow, respectively. Such defects usually occur because of excessive clearance between the center hole and the spindle of the playback turntable. Occasionally, wow of this type is caused by carelessness in manufacture of the record. Fortunately, most recording companies have tightened up on their center hole tolerances so that most modern pressings are substantially free of these troubles. With the advent of the Components Corporation Professional Model PBT turntable, something new has been added. It is now possible to accurately center a pressing by use of an exclusive expanding collet spindle. This expanding collet eliminates the tolerance problem between the oversized hole and the usual undersized spindle, especially those necessary on record changers. There is another serious source of wow which arises from the tendency of most modern vinyl pressings to run slightly out of flat. The resultant up and down motion will yield a wow from a slightly non-flat record, even though it is properly centered and accurately made. Only a few pickup arms having the horizontal pivot axis exactly in the plane of the record surface are completely free of this source of wow. Components Corporation is concerned about the disregard for this fundamental principle and has designed an arm which can be adjusted to eliminate this source of wow. Flutter is a faster variation in turntable speed, which usually can be blamed on the idler runout. The effect of this kind of defect is to add a vibrato or warble, something like these tones. These samples of flutter were produced by deliberately altering an idler to produce 0.5% and 1% peak-to-peak flutter respectively. When flutter occurs at a much faster rate, it is difficult for the untrained ear to recognize it as a pitch variation, chiefly because of the hearing process. Fortunately, high-speed flutter is not frequently found in the better turntables. It does occur in many tape machines and may thus be cut directly into the master recording on occasion. The oscilloscope test to be described shortly is best suited for observing this type of defect. High-speed flutter tends to muddy up reproduction of complex musical chords, and most particularly violin passages. A small amount of high-speed flutter seems to be built in even to the finest tape recording mechanisms, so that the special test tones on the other side of this test record were recorded directly from a highly stable electronic oscillator. Of course, they were recorded on our new hydro-feed master recording lathe, which is the only machine designed with the horizontal pivot axis of the cutter in the plane of the recording surface. This fundamental principle has already been mentioned previously in relation to proper playback arm design. In addition, a special electronic driving system was used to isolate the speed of the recording turntable from variations in power line frequency. The overall stability of the tones on the other side is better than 0.1% of 1% peak to peak, or 0.05% RMS. The flutter component is even less than these figures. The inner band on the reverse side is a 3,000 cycle tone, which can be observed by a critical listening test and compared to the examples given above as to magnitude of the wow and flutter observed. For more accurate measurements, a commercial flutter meter can be utilized if available. If a flutter meter is not available, the outer band has a 100 cycle tone, which can be observed on an oscilloscope with the aid of a stable oscillator capable of being adjusted to 100 cycles. There are many such oscilloscopes and oscillators in most every neighborhood as a result of the popular kits which have been offered widely during recent years. In order to use this equipment for observing turntable performance accurately, the output of the pickup and the amplifier should be connected to the vertical amplifier of the oscilloscope, while the 100 cycle oscillator should be connected to the horizontal amplifier. The sweep control should be set to external. Play the other side of this recording at 33 1/3 RPM and adjust the oscilloscope gain controls for approximately equal deflections of 1 or 2 inches. Then slowly vary the oscillator frequency dial until a moving pattern stops. As it stops, it will slowly vary from a circle through an ellipse to a straight line and back to a circle again. Since we are looking at 100 cycles per second, a variation of 1 cycle is of course 1%. This would correspond to a variation in a pattern from a circle to a line to a circle through a line and back to a circle again. Of course, such a large amount of wow as 1% is much too much. A variation of the circle down to a straight line is just 1/4 of 1% peak to peak, or approximately 1/10% RMS for sinusoidal variations. Since this is the figure most frequently quoted in the advertisements, practically all turntables should therefore have their short-term variations contained within a fairly stable circle, or at most only a variation from a circle to an ellipse, but never collapsing into a straight line completely. There will always be some long-term or slow drift in the pattern, which may be due to a gradual drift in the local power line frequency, or warming up of the turntable motor. It is well to allow most turntables to operate for at least 15 minutes, and the 100 cycle oscillator may require warm-up for 30 minutes or more for stabilization. Our model PBT turntable motor is an exception to this warm-up rule. It will assume correct speed within a few seconds after it is turned on, irrespective of temperature or line voltage. Line frequency will of course affect it, as it will any other synchronous motor. Excessive bouncing vertically of the pattern may be caused by stray pickup due to hum or other stray effects. Running the oscilloscope gain too high and the amplifier output too low will aggravate such stray pickup. Rather slow bouncing can also result from an unstable arm mass and stylus compliance resonance, which is excited by the once-around rotation of the record. Changing to a different pickup and arm may correct this latter condition. Scratches in the record will also cause a vertical bounce as they pass the stylus.